I fear the smart contracts of the future if this happens.
We just needed to run our own blockchain if we wanted to deploy our own systems to it. And that's kind of where Base came from.
Sometimes it feels like we're just fiddling with RPCs and debugging errors most of the time.
I live on GitHub. I don't really live on Twitter. I just like writing code, and so hit me up on GitHub if you want.
Welcome to the Coinbase Developer Podcast, a technical deep dive with top on-chain builders in crypto and beyond. I'm Yuga Cohler, engineering lead at Coinbase Developer Platform.
And I'm Erik Reppel, head of engineering for CDP.
Erik, in crypto, every year, supposedly the year, we're going to onboard 1 billion users. And you and I are in the trenches. We know that sometimes it feels like we're just fiddling with RPCs and debugging errors most of the time.
Yeah, it turns out scaling Ethereum is hard. It's a lot easier to write blog posts about it than actually do.
Absolutely. And that said, though, we know there's a lot of exciting things still going on in Ethereum. And one of the few projects that's making a ton of progress is the network that we all know and love, Base, the L2 that came out of Coinbase, one of our dear sister teams with CDP, and it's become one of the most used chains in the ecosystem.
Yeah, the engineers on Base have done a great job scaling Base and pushing forward the scaling roadmap. They're some of the most cracked engineers in the ecosystem. And today we have, I think, chief cracked engineer of Base on.
Exactly. So we are super excited to have Coinbase vet, principal engineer of Base, Michael DeHoog. Michael, welcome to CDPod.
Hi, thanks for having me.
So just to start off, we'd love to get to know you. I mean, you were one of the engineers that actually interviewed me about four and a half years ago. You've been at Coinbase for about 8 years now. Just tell us a little bit about your background and what you've worked on at Coinbase.
Yeah, so I joined Coinbase as a pretty junior engineer, just a full stack engineer back when we had about 50 engineers, I think. And everybody did everything back then. It was a startup. And quickly became apparent, this was during the ICO boom, I guess, in 2017. It quickly became apparent that we needed to scale Coinbase.com. And so pretty much worked on that for 4 or 5 years. Mostly on the back end infrastructure, a lot of database work. It was very much not really a crypto role. It was more like a tech role, I would say. It's just scaling a Web 2 platform, but learn a lot, obviously. It was exciting to see the growth of Coinbase and the growth of the platform, and we just at times we didn't have enough people to keep up with the demand, which was really exciting. So that's kind of my background, and then Base came up as an opportunity. I had a child and went out on a little bit of leave and came back, and we wanted to bring Coinbase on chain, and I can go into a little bit more backstory there if you're interested.
I remember that time of Coinbase fondly. I was an intern when Michael DeHoog joined. This was roughly the same time Jesse joined, actually, I believe.
Yep. Yeah, I beat Jesse by a month. I always like to tell people that.
I think I beat you by a month on my intern start date. Yeah, I remember I actually think I helped Jesse with his first PR at Coinbase. That's my claim to fame. Contributor -1 to Base. I think the goal here is to really talk through some of the technical aspects of Base, and how do you go from that moment where you come back from pat leave and then you and Jesse are like, okay, it's time to build a blockchain. What was the first week of engineering Base like, and what did it actually take to go from 0 to the biggest L2 currently running on Ethereum?
Bringing Coinbase on chain was initially nothing about building infrastructure or building a blockchain. We had a bunch of different prototypes or projects that we worked on. We pivoted pretty aggressively as we tried to find product market fit. And one thing we did agree on was we did want to build on top of Ethereum. So we built a whole bunch of different prototypes. We built an app store. We built an identity system. We built a bit of a wallet prototype. And the thing we kept coming back to was, where do we deploy this? We want to be Ethereum aligned. We want to deploy to the L1, but our users aren't going to pay those fees. So we have to kind of choose an L2. Which L2 do we choose? Coinbase is a pretty big player. If we choose one of these, we kind of have to like really commit to that one L2. It became pretty apparent pretty early on that we just needed to run our own blockchain if we wanted to deploy our own systems to it. And that's kind of where Base came from. At the same time, as we were prototyping these things, we were spinning up our own proof of authority blockchains internally, running on our internal infrastructure inside our VPC, only accessible to internal employees. And so that gave us a bit of a feel for running a blockchain. It was really useful. We had unlimited gas, right? So we could just like build faucets and give people millions of ETH. And then it was a really good place to test contracts on and keep it sort of private from the public blockchains. And then we actually started running an L2 on top of that internal blockchain. So we called the first one CoinNet. And because of Coinbase, we called the next one Base Net. And that's kind of where Base came from, right? We were running an L2 internally. We're like, oh, this is cool. Maybe we could externalize this. So yeah, we decided to run an L2. We didn't have the name Base yet. We just we're running a blockchain. It's going to be an L2. It's probably going to be an optimism. And then Base as a name came later. And then we launched a test net at an offsite in California in the forest, which is a lot of fun, where we had like backup internet using Starlink. Yeah, and that's kind of where Base came from, a need for block space, I guess, if that makes sense.
It's funny. I remember the days of CoinNet and like there was like a faucet that you could use. It was a fun time. So you had this L2 where that was, I guess, posting blobs to a proof of authority internal L1. And the idea was to externalize this base net to the outside world. But at CDP, we're in the business of externalizing internal APIs, and it's never as simple as it sounds, right? Like often it's just like, you think it's an API, it should work in the outside world, but internally there are a ton of assumptions that you make, in terms of authentication or how people might access your services, et cetera. So what was that delta like between going from BaseNet to actually Base?
Yeah, well, suddenly we couldn't just run something on a single server, right? We had to spin up nodes, and we had to separate the concerns of different nodes to do different things as well. And so we built up this entire infrastructure for externalizing this network. Well, some of the particulars there, for example, you run a sequencer node, which is responsible for taking transactions from the mempool, ordering them. We just use a very naive fee-based ordering mechanism. There's no MEV capture or anything like that. And then filling up a block, putting that block, gossiping that block to other nodes. And so there's a sequencer node that's sort of like the core of the network, right? That's putting the transactions in order and creating the blocks. We want that to be not exposed or not externalized at all, because it's a very important node. We don't want people to be able to like DOS it or abuse it in any way. But we do need some way of getting those transactions into that node. And so we spin up separate nodes that are public mempool nodes, which users then submit transactions to. And those transactions are gossiped to the sequencer node using the mempool gossip protocol of Ethereum. And then we have a bunch of other nodes which are responsible for gossiping blocks once the sequencer builds those. And those ones are publicly peerable to other nodes. And so we kind of have three sets of nodes. The sequencer is a single node, or a single machine, because you don't want to have competing machines trying to build blocks, because then you get forks, basically. And then you have some scaling groups of nodes for the mempool and scaling groups of nodes for block gossip. And that's kind of what the initial infrastructure looked like when we launched. And now, of course, CDP runs their own nodes, and again, people can use those as RPC nodes, but the core protocol, or the core nodes, are still there. We have a sequencer, we have mempool for managing the transactions coming in, and we have these nodes for the block gossip.
To pop off the stack like three layers, because I don't know what this is. What is proof of authority? Why did you start with like a proof of authority blockchain running internally?
Yeah. Well, proof of authority is this idea of a single private key can seal blocks or generate blocks and seal them and say this is the canonical block. That's the authority of the network. And it's just a really easy way to bootstrap a blockchain. If you want to do proof of stake, then you have to have like staking nodes and you have to like spin those up, and it's just a little bit more complex. And so proof of authority is just a way to run like a DevNet, basically, or an internal test net that doesn't have any decentralization. It's just a centralized role that is responsible for building blocks.
Base has been pretty involved in like the Ethereum roadmap and the OP stack over the years, and I want to like, and there's been a lot of work that's kind of gone through with that. Like, you know, Base launched before we had like blobs and like the blobs hard fork. There's been just like a lot of these progressive changes in Ethereum to enable L2s to really like work and be as cheap as they are now. Like, what are like some highlights from that, or like some things that you found particularly interesting in that roadmap?
You mentioned blobs. The 4844 proposal and implementation was the first time Coinbase really got heavily involved in Ethereum protocol development. And we saw that as a needed change for our users to be able to get cheap gas fees, because and you see like the drop off when 4844 happened or was enabled on mainnet. The L2 fees dropped off a cliff. It was a very successful launch. And yeah, it was really exciting just to get involved and like see what it takes to roll out a Ethereum protocol change. It's not just like implementing it in one place, because you have to implement it in multiple nodes and you have to get alignment with all those node maintainers. You have to run multiple test nets and get people to join the test net so they get confident that the change is working. And then you have to roll it out on their like official test nets like Sepolia or Gorelli back then. And so it's like it's a long process to get a change out, including the like social consensus that it's a good idea. Yeah, and it was fun to be exposed to that and to help with that and to really feel like we're making a difference. So yeah, 4844 was the first time we really got involved. And then since then, we've been involved in things like the SecP 256, P1 curve, the passkeys signature change. That's been really helpful for our smart wallet on Base. And we've been involved in countless OP updates as well. One of the early ones I remember was getting the batcher to be parallelizable. The batcher of the OP stack is a very modular framework or piece of software. And each of these modules are responsible for small parts of the system, I guess. So you have a sequencer, which we mentioned earlier. And the sequencer is responsible for building blocks, but it's also responsible for submitting those blocks back to the L1. And the piece of software that does that is called the batcher. And early on, the batcher could only submit in single transactions to the L1. There was no and then it would wait for 5 confirmations or something. And so your transaction data, you would fill it up, and then you could only submit one every 5 L1 blocks, which was fine for the scale that OP was running at the time. But we really wanted to push the gas limits and push that a little bit further. And so we implemented parallelization to that batch processing, which then, of course, was picked up by the blob submission. And that just allowed us to increase the throughput of the L2 pretty significantly.
I think like the topic of throughput and latency are top of mind for a lot of protocol developers. Like, how fast does something land on chain? How many transactions per second can a chain support, for obvious reasons? And a lot of the things we see coming out from Base right now are like the prospect of, first of all, the consistent gas limit increases week over week, as well as, there's news hit, I think like last week, around 200 millisecond block times. Can you talk a little bit about like, what are the engineering bottlenecks that make achieving that difficult, and like what's the engineering work that's going on behind the scenes to enable those things?
Yeah. Well, we have a whole roadmap of blockers or bottlenecks, and each bottleneck sort of kicks in at a certain gas per second number, and so we're working through those bottlenecks. One of the biggest ones, of course, is state growth and like state management. So our Geth archive nodes were hitting something like 16 terabytes and increasing pretty dramatically each day as we increase the gas. And so we've already sort of turned off Geth archive as an option for node management, and we use Reth for our archive nodes, which has a much smaller database. We are also at the same time writing a new database called TreeDB, which is some of Brian Bland's ideas, and a bunch of engineers on the base team are working on that at the moment. The idea being we can make that database even smaller and more efficient. And so that's really going after the state growth aspect. Our goal is to get a gigagas, and we're a long way from that. We're something like 30 times from that. I think we're at 33 million or something. To hit a gigagas, we have to fix the state growth. We have to probably have to have some kind of parallelization. One of the things I'm most excited about is the ability for contracts to be executed independently or like in parallel, so that if you have some large NFT launch or something, it doesn't just bottleneck or it doesn't saturate the entire network, so that other users can just use the network and not be affected by the gas spike that's being brought about by that popular NFT launch. And we already see other networks have like local gas markets for contracts. So I think implementing something like that is going to be a required step in our path towards gigagas. Those are some top of mind things for me at the moment.
I went to Frontiers, which is like the Paradigm Rust crypto conference last year, and there was like a really interesting talk by this guy behind I think it was PEVM, and it was like it was basically trying to do that of like parallelized like EVM. And it's really interesting to me, that particular topic, because I always thought that like we're now at the point in crypto where we should start stealing the ideas of like Web 2, like distributed systems optimization and performance. Like I think that there's like not a ton of knowledge I think some crypto builders have this knowledge, but there's some of these problems have been solved, right? Like the classic data flow paper out of Google is kind of like how you do distributed like graph based breakdowns of problems into sets. It's kind of like the successor to MapReduce, where MapReduce is like just map everything and then do a reduce, and data flow is like, no, actually turn everything into a DAG of dependency and then process all, basically do as deep of a traversal as you can without getting to the point where you have a dependency, and then do the reduce just on that set that the graph converges on. So it's super, super interesting stuff on the optimization side, I think.
It's really hard to. I agree. We should be borrowing a lot from what Web 2 has solved, and there's a lot of papers around speeding up distributed transactions, and there's some more recent ones on using RDMA, remote data direct memory access, for your like distributing your memory or your storage, I guess, on multiple machines, but still having really low latency reads and writes. But the tricky thing with blockchains is that you have to reach consensus on the order of transactions, and you have to have a authenticated data store, which for Ethereum is the Merkle tree, and of course there's discussions around maybe switching that to something else a little bit more performant. But in the end, you still need to hash it into some like authenticated hash, right? And so it's not as easy as just like having a distributed key value store, because there's some additional requirements that you put on top of that.
Yeah, you need to like rehash the tree periodically, and you need to, and that's I think like one answer as to why I think some people, when they get into crypto, they're like, why is like node storage usually stored like on one logical disk? Like, why are people so worried about state growth? Like, can't you just put this on a distributed file system? And it's like the lookups of data if it's on a distributed file system, become really poor. And there's a ton of disk usage when you're operating node, both during sync and during like contract execution to look up slot values. And also like because it's a tree structure that needs to be rehashed occasionally, if you had like a network involved in every lookup, you'd have like potentially pretty bad latency. Although modern inter-cloud metal networking is pretty quick these days. I think there is going to be like a potential path someday for that.
Yeah, and that's the nice thing about the Ethereum design, where it scales via layers, or like L2s and then potentially L3s. Those layers can be increasingly more centralized depending on their needs, right? App chains don't necessarily need to be decentralized because they're running a certain app for a certain like developer or a certain product. And so you have a little bit more freedom at those layers to maybe use more powerful hardware or like roll out a different Merkleization scheme or something like that. And that's something I'm really excited about. And of course, CDP has app chains, which we've launched as a product. And I think one of the things I'm really bullish on, and something that I think we should really focus on is scaling those more centralized app chains without having to, as a learning platform or as a prototyping platform for potentially applying some of these things to base and then the L1.
So we're recording this on April 22nd, 2025, kind of in a similar area around like optimizations to the EVM. Vitalik just came out with a blog post on the potential of replacing the EVM with RISC-V architecture as a mechanism for enabling things like making block production more competitive on the L1, enabling ZK EVM proving capabilities, things like that. Have you any thoughts on this? Or like, it seems like a fairly, not necessarily radical, but it would be a very intense shift in how the L1 operates, but curious to get your take on it.
I haven't actually seen this one, but this is really cool. Yeah, of course, RISC is, there's the RISC-0 team, of course, which has a ZK version of running a RISC-V VM. And you can buy RISC-V hardware, right? And so you can imagine speeding up Ethereum with something like this. But like I said, I haven't seen this this proposal yet, so I can't comment on it without looking a little bit deeper. But it seems like a good idea.
I have
and Vitalik is very smart. Everything he posts is gold, and so we should take it as a good idea to begin with, I think.
I 100% agree. You should take all Vitalik ideas very seriously. As someone who's written a lot of smart contracts, I really wonder what the interoperability story, because I think this would break the smart contract paradigm the EVM currently has. That being said, RISC-V is really interesting because it's an open source instruction set. And I don't know if you've heard of like SP1 or like some of the new ZK VMs that basically they let you write, SP1 lets you write like arbitrary Rust, and then they have like they have a ZK VM that is like fully RISC-V compatible. And so they compile your program to RISC-V, and then they can translate any RISC-V program into a ZK circuit, which means that you can just write Rust and then get like a ZK circuit on the other end, which is like super cool. And so I do like RISC-V as a shelling point. I fear the smart contracts of the future if this happens. This seems like almost seems like a proof of stake level difficulty on hard fork.
Even more than proof of stake, right? Because proof of stake didn't require engineers to change their bytecode or anything like that. It was more like a protocol layer change. But I imagine there'd have to be some compatibility layer that runs the EVM on RISC-V that uses more gas or something like that. And this is for like going forward, and people can choose to redeploy, and maybe there's some like upgrade ability or something for existing smart contracts. I'm not sure.
Speaking of smart contracts, you mentioned that you were part of the base, that base like helped get the I always forget key names, but the passkey curve adoption. I think it would be really interesting to describe like what it actually takes to add a new curve to the EVM, because I think like the passkey curve, to folks that don't know what it lets you do, passkey is a public private key. You can think of it as a public private key that's like widely adopted by big tech, and so you can have a passkey that's tied to your Google account or your Apple account or 1Password. There's a bunch of these different providers that have all like kind of centralized around passkey as like the authentication mechanism of the future. And so being able to verify passkey signatures on chain is like a huge unlock, because now you can authenticate to smart contracts using something that theoretically is available to every single person in the world who has like an Apple, Google, or other like big web player account. I think there's like, the UX on passkeys varies from device to device, but it would be super interesting to talk through like, how do you actually go about adding that kind of curve to the EVM?
I think the biggest trouble is getting social consensus that it's a good idea. The actual implementation, of course, there's like, this is a very well-known curve. It's used in large systems. Google and Apple use it, right? And so there's implementations in many languages that have been used for many years, audited and checked for validity, and so we're pretty confident on the security of these types of changes. It's more that you need to get buy-in from all of because it's a decentralized network, you have to get buy-in from different node maintainers. You have to implement each of those as pre-compiles in those code bases, and then you have to roll it out. You have to choose a hard fork to roll it out at. You have to get consensus that this is a good proposal to roll out at for this hard fork.
But so the way that actually works, like I think like all engineers who reach like a certain level of maturity realize that social issues are like 90% of the problems of engineering once you get to a certain threshold. You mentioned like you have a pre-compile of this curve. It's like you're using the implementation of a curve that's like well audited and well understood. And that pre-compile gets added to all the nodes across all the different clients that operate on these blockchains. But then like, how does that actually translate into, I'm a Solidity developer and I can now recover a signature in my contract? Is that like a new opcode, or is that like, how does that mapping in the EVM work where your Solidity code can now go and access that curve?
Yeah. So at some point in the past, I can't remember the first precompile that used this, but the Ethereum community decided to stop adding new features just via opcodes, and also add this ability to add cheaper contracts, which are called precompiles. And so a precompile is essentially a piece of native code that runs more efficiently than a piece of Solidity or a piece of bytecode, that is accessible on a predefined contract address. For Ethereum, the first precompile is 0x1 address, and then 0x002, 3, 4, 5. And so the way that's exposed to Solidity developers is you call a contract just like any other contract call, but it happens to have that special 0 prefixed address, and you get that functionality behind that call. And then Solidity will then evolve to then support that particular precompile at a language level at some point. So generally, like when the R1 curve was added, the early adopters would just use it by calling that precompile contract directly, and then eventually Solidity will then support it as like an ECU recover type thing.
On the topic of like social consensus and getting agreement or buy-in from an ecosystem, Base famously launched without a token, right? Its native gas token is ETH. A lot of other networks incentivize usage of the network by bootstrapping token, some sort of airdrop or something like that. Base didn't do that. Base, of course, had the backing of Coinbase, which is obviously great. But it seems like, you have a bunch of nodes, different types of nodes. You have sequencers, you have the gossiping nodes, et cetera. But it seems like there has to also be just a bunch of other software or ways to make it really, really easy for developers to access Base in order to incentivize usage. So what does that take? Like, early days of Base to now, like what is the full ecosystem of things that the Base team helps with to make it easy to develop on Base and make it a really good experience?
I guess there's three classes of users of a blockchain. There's, of course, the end user. And so you need to have a good wallet implementation that gives you like a front end access to that blockchain. And so, of course, we built the smart wallet, but of course, there's Coinbase Wallet, and Coinbase Wallet is evolving into being more Base focused, I guess. And so it's really important to have a user friendly place where users can go to just access these applications that are running on Base. And then there's the developer side, which you need things like indexes, RPC nodes. For context, an indexer is something that takes data from a blockchain and looks at events or transfers or like movements of money and puts that in a queryable database. Because a blockchain is really just a bunch of blocks that have transactions in them. Some of those transactions will emit events. But there isn't a really good way on a native RPC node to just query a large amount of history or something like that. That can become expensive. And so indexes can sit on top of blockchain nodes and provide access to different types of data or data in a different type of structure. Yeah, so that's a really important piece of infrastructure for developers. RPC nodes I mentioned, just access to the blockchain. Things like paymasters, which are things that developers can use to cover gas costs for users. And a paymaster is in particular something that's part of the 4337 EIP, which is an account abstraction EIP, which is basically a smart contract wallet there's two different types of ways of accessing a blockchain. You can use an EOA, which is like a public-private key pair that you can submit transactions from, and that's where all transactions are initiated from for a blockchain. And then you can have smart contract wallets, which have some logic in a smart contract for managing assets or managing access to that wallet. And those smart contract wallets can be a little bit more powerful in that the transaction from a smart contract wallet can be initiated from a separate EOA, and it can call that smart contract in an authenticated way, and it can cover gas costs. That's what paymasters do. And so that's another important piece of infrastructure for developers. And I mentioned three things. The other thing that's important is to get some economic activity by convincing like market makers to have liquidity pools and like convincing Uniswap to run on your chain or like other DEXs. And so just having a vibrant ecosystem of like money movement and like liquidity and TVL is also important for bootstrapping a blockchain. So that's kind of the three things that we needed to focus on. And yeah, we really focused on making that good on Base. And like you said, we don't have a token, so it's not we can't incentivize people through token grants. We do have this idea of retroactive public goods funding, which is something that Optimism uses to reward builders that build on OP Stack networks. So yeah, that's a good incentive mechanism. We also just we rely on the vibes, like the Base for everyone. We have a lot of users on the Coinbase side that we can bring onto Base. So people are just really excited about using Base and getting access to those users, and users are excited because they get access to cool apps, and it's just it's a good flywheel to build up.
I would actually add a fourth category to that, Michael, from my experience launching Zora Network, which is like another L2 on top of the OP stack. Fun fact, we beat Base to market by about a week, and you can check the chain for proof that our block number is slightly higher than Base's with the same block time. We cheated though and used Conduit to help us out. You click, this has gotten a lot better. I think the OP Foundation has done a lot of work based on feedback from Zora and other folks. But you click now deploy blockchain, and now you have an RPC URL you can like submit transactions to, and you have like all the stuff. And the nice thing with ETH RPC and the Ethereum standard is that your indexer, for the most part, is going to be pretty portable if it's like an event-based indexer from one chain to the other. And like your UI, it's going to work. You just change the chain ID and the URL to a new RPC. You get a lot of compatibility out of the box. I think the thing that people don't realize is that like a base EVM isn't actually that useful for the modern day Solidity developer because of the amount of like composability within the Solidity ecosystem that most chains have. So like one example is like Zora uses Gnosis safes for a lot of stuff. Turns out if you have an empty EVM, you don't have access to the Gnosis safe contract. You have like all of these like multi-calls, another example. Like a lot of front ends use this multi-call contract so that you don't have to do multiple RPC requests to get multiple pieces of data from the blockchain. You make one RPC request and you can call multiple view functions across like any number of contracts. And this actually became like such a big problem for us that we like built up tooling to like copy contracts from Ethereum to Zora network to like help bootstrap those like utility contracts that our protocol depended on. And I think that ended up being like almost a third of the work in building Zora network. Again, we didn't have to do much on the like node running side. We had to run our own nodes, but Conduit helped us out a lot with all of that. But building that ecosystem where you can just drop a Solidity developer in and they can actually be productive, I think is like a really underappreciated aspect of it. But thankfully, I think it's a lot better now than it was like 2 years ago when this was all happening. Because like I think OP and these other L2 kind of frameworks, Arbitrum, etc., are realizing that you need to kind of have these precompiled contracts that get deployed along with your L2 for your L2 to be useful. And like you should probably just have precompiles deployed at the addresses they already are at on Ethereum mainnet, and that just like makes the ecosystem bootstrapping significantly easier.
Yeah, I forgot about those early days when we had to deploy like the deterministic factory and the multi-call contract, and we had to convince Safe to do it because Safe used their own way of deploying things. And yeah, it is tricky, and I agree. The OP Stack has come a long way with the pre-deploys, and now app chains as well. We're doing a lot of pre-deploys for those factory contracts and multi-call and making sure Safe is there. So it's a good point.
I think kind of something related that comes to mind is like, so for instance, like ENS, right? When ENS registry is really only on the L1, and if you have a Web 2 interface, you can kind of hack together where you fetch from the L1, then resolve on the L2. Of course, there's base names on base itself for like if you want to register that, but like canonical ENSs are only on the L1. Can you talk a little bit about, so like, I think that ties into this broader issue that Ethereum is facing around interop across chains. And it feels like Optimism is trying to solve this with the superchain, but would love to hear like, what are your thoughts on like where we're heading with all this, like how interop is going to be solved, and is the superchain like part of that solution?
OP Stack interop is really interesting. And I think it's going to solve for the OP Stack chains, and it's going to be a really good experience for OP Stack chains. Unfortunately, OP Stack chains are, the super chain is not the only thing. There's other chains out there, and I think like we need a broader interop as well. I think this is becoming more and more clear to the L1 as well. There's been a bunch of discussion around the L1 being a little bit more open and supportive of L2s. Just because, this is part of the Ethereum scaling roadmap. When the L1 is going to scale through these L2s, and so there needs to be a little bit more native. And one of the initiatives there is based rollups, with the idea that the L1 validators are producing the blocks for the L2s, and so you gain some decentralization and security from that. And you also potentially gain some interop because your validators are building blocks, they can also ensure that transactions from two different L2s are included in the same block, and therefore there can be messages past that. So there's a bunch of ideas around this, but I agree it's a under implemented space right now. It's a lot of ideas, but not a lot of traction or not a lot of implementation. And the OP stack interop is a good solution that is being rolled out and something that's been implemented. I think also as ZK improves and we reduce the finality of writing proposals or like output proposals back to the L1, which is the commitment that lets you prove something about an L2, we're just going to keep on bringing that, like the time it takes to prove that lower and lower. And that will inherently allow messages to pass between the L1 and the L2 a little bit quicker. Sorry, the L2 and the L1. But in terms of like decentralized trusted interop that's, sub-second, I think we're a little ways away from that.
We have 2 questions we like to ask every guest, and I'll give them to you at the same time. The first question is, what piece of technology in crypto are you most bullish on? Like, what technical change are you most excited to land, or theoretical thing that would solve a bunch of issues in your mind? And then question number 2 is, what do you think CDP could do to accelerate builders in crypto?
The thing I'm most bullish on, I'd have to say the ZK stack and the ZK tech. It's just moving so fast, and there's so many exciting developments happening, and speed of proving is increasing, and people are building hardware. It just feels like the early days of crypto to me, and it's just going to change. It's going to change the world, not just crypto, but the rest of the world as well. So I'm just really excited about that, and I hope we can. It's so hard because it changes so quickly that it's hard to know which things to enshrine into the L1. Like there was a point where you say, "Oh, we need the Poseidon hash because we don't have a ZK friendly hash function in Solidity, so it's really hard to, interrupt between the two." But now we're speeding up SHA hashes, and so maybe that's not a good idea. And so it's really hard to know, okay, when do we actually adopt some of the ZK stuff in the core protocol? But yeah, I'm really bullish on that. Things that CDP could do, I think people just want cheap block space. And so like the app chains product is really exciting, and I think we just need to scale that up and like go to a gigagas with that, because it can be more centralized, and so we can roll out some more interesting things. Maybe we don't need like a Patricia Merkle tree or something for the authenticated data store, or like maybe we can have some parallelization there. I think there's a little bit more freedom in what we can build, and I'm really excited about giving people block space and as much gas they can use as possible.
Totally. I want to make sure we give full credit to base L2, base L3s, and everything to the base team. CDP was very minimally involved in that, other than letting base service it through our portal. But we do want to support the L3s as much as we can in the CDP offerings, like our server wallets offering, or wallet APIs. It's known externally, supports signing for any arbitrary L3 from day 0. And I think I got to go talk to the base builder team about getting some RPC access for folks so we can do send transaction as well.
Yeah, that's a good point. Making it as compatible as possible is a really good point as well. Yeah.
Well, this has been awesome. Thanks so much, Michael. And is there anything you want to plug? You want to shout out a Twitter or anything like that?
Not really.
Check out base.org. Follow Jesse.
Yeah, you gotta check out base.org. I live on GitHub. I don't really live on Twitter. I just like writing code, and so hit me up on GitHub if you want. It's just github.com/DeHoog.
Spoken like a true cracked engineer in chief of Base. This has been awesome. Thank you so much, Michael.
Thank you.
Lead the world's transition on chain by building with Coinbase Developer Platform. Visit us at cdp.coinbase.com. Follow us on X at Coinbase Dev, and be sure to leave us a review on your favorite podcast app.